right, welcome to Lecture 1, officially. Today we're going to talk about human ecology and physical geography, all right? I've got my volcano dress on. I'm ready to rock and roll. So, I keep using this term, human ecology, and I probably need to define it for you. So let's start with just ecology generally. Ecology studies the interactions between living organisms and their environments. It's pretty straightforward. As a human ecologist, I'm doing the exact same thing. It's just that my unit of study is people. So, as we go through the course, one way to think about this is that we're aliens, and we've come to planet Earth, and we've been assigned the species Homo sapiens. And it's a tough task, okay? But just like with any animal, when we start trying to figure out the ecology of humans, we need to start with their habitat. All right? So that's what we're going to do this week. We're going to talk about human habitats, the environments that we live in, and today we're going to do geology and geomorphology. So, geology is the study of the Earth's physical structure and composition. We're talking about rocks, soils, erosion, basically what's under your feet, okay? This is the canvas on which human societies are built. So, we're not a geology class, we're a human societies class. So, the question then becomes, well, how does geology influence how people live, right? So, one way is building materials. You've got a picture there of a stone house. Depending on where you go in the world, houses, buildings, roads are made out of different things. So sometimes you'll see stone houses in places where rock is easily mined, but then you'll see wood houses where there isn't a lot of rock. Maybe it's a lot of sand, or the rock is extremely hard. In the United States, if you drive around on the interstates enough around the country, you'll notice that a lot of times the asphalt is different colors. In Mississippi, for example, it's really red compared to what it looks like here in Texas. And that's because they're using local rocks, grinding them up, and then using them in the asphalt. Excuse me. So, another thing is soil. So what is soil? Soil is eroded rocks, right? So it's little bits of rock, and then it's also humus. So it's organic material that has decayed from other sources. Those things are mixed together, and that's what plants like, right? So the type of soil you have is going to limit what you can grow. If you go to France, they'll tell you a lot about the terroir of their wines. So, oh, well, this valley has white slate, and this valley has black slate, and so the flavor of the wine is different from one valley to the other. I'm not a wine person. I couldn't taste it, but I have to take their word for it, right? But these are conversations that people are having about their dirt. Now, the soil that you have available can also lead to nutritional deficiencies. So one example would be if your soil doesn't have enough iodine in it. Iodine is a nutrient that's important for your endocrine system. If you don't get enough iodine, then you will start to develop large goiters on your neck and in other parts of your body. We have iodized salt in the United States. It's very common for most of your salt, unless you buy sea salt, to be iodized. And the reason for that was because people were suffering iodine deficiencies. So the public health people said, well, let's go ahead and add iodine into the food supply somewhere, and boom, goiter's not a problem anymore. So that is kind of an ideal version of how public health should work. And then your geology is also going to lead to what kind of health hazards in some ways that you have around. So we'll talk about volcanoes in a little bit. That's a pretty obvious health hazard. But even just the kinds of rocks that you have. And I'll show you an example of that in a minute. So you're probably familiar with Easter Island. Its formal name is Rapa Nui, right? That's the name the people that lived there gave it. And the reason that it's so famous is because of these giant stone heads, right? And so the building materials that your civilization has available and chooses to work with influences a lot, including how well your civilization is remembered. Okay? So when we think about, ancient civilizations that we remember, we think about the Egyptians and their pyramids, we think about Stonehenge, we think about Angkor Wat or Great Zimbabwe, these civilizations that left these giant stone monuments to their accomplishments, right? There were plenty of other civilizations, probably more, that were using wood, and it's rotted away. And so their memory didn't last as long as rocks. So for a more modern example of how geology is going to affect people's lives, let's go to Wittenoom, Australia. Wittenoom is a small town in northwestern Australia, kind of in the middle of nowhere. And for 30 or 40 years, they were a really important mining center for asbestos. Okay, asbestos is a naturally occurring mineral. It was used for a lot of purposes, especially insulation, because it is fire retardant, okay? But asbestos is very, very, very bad for your health. The fibers of asbestos can get in your lungs and cause mesothelioma, which is an extremely aggressive cancer. And that is a major problem. And so around the world in the past few decades, there has been a big push to try to remediate and remove asbestos in people's homes and businesses. But we also need to go back to the original source to say, well, what's going on with the places that created that mined this stuff? And it's not good. So the waste tailings from the asbestos mines were just kind of passed out. And you'll see this a lot in mining towns. I've even seen it with yellow cake, the spent materials from uranium processing, where they hand out just these tailings, these the trash dirt basically from the mines, and they're using them to build roads and buildings and housing sites and playgrounds and all kinds of things. And so what you've done is you've spread the asbestos all around the community. You've put it in places where it can wash into the rivers, and essentially you've made your town unlivable. And so that's what happened. The town was slowly evacuated over several decades. By 2007, it was officially closed. Today, there are only a couple of die-hard outback people living there. And it's a real tragedy. You had an estimated 2,000 to 4,000 former residents die of mesothelioma. And that is a thing that continues to happen. The death count from Wittenoom continues to increase. So here's a picture from Wittenoom. This is a canyon outside of the town, and this is one of the things that draws people out there. It's beautiful, it looks like the Southwest. But in the foreground, that big gray pile is just a pile of asbestos tailings. So it's very obvious how dangerous this is and how easy it is for it to wash away and into the rivers. Now, currently, we have a bit of an issue with Wittenoom. So the article is calling them YouTubers, but I mean, you guys, they're people on the internet that are willing to say things. We have a bunch of people, particularly it looks like young people, who completely ignore all of the signs about how dangerous the asbestos is. All of the things that should make you go, I don't know that I should be here when you drive through a ghost town. But going out there to hang out and swim and take pictures, and exposing themselves to very dangerous things. And I'll tell you something. 6 months ago, this would have shocked me a lot more. Now that we live in coronavirus world, I think we all kind of have a better handle on who these people are, right? So, pretty sure all the asbestos is solid, no fibers. That's not how it works. Just like with the virus, you're not going to see it coming into you. You're not going to be able to turn your head because there's a fiber in the air. It's dust. It's invisible. It gets in and then it wreaks havoc with your body. So, yeah, I'm going to ask you guys not to do stuff like this. It's just not smart. So, geomorphology is related to geology. It's just at a larger scale. So geomorphology is the study of the physical features of the surface of the earth. So mountains, caves, valleys, plains, volcanoes, right? Where we talk about, oh, what kind of landforms? That's geomorphology. So probably the number one thing that we want to talk about when we talk about geomorphology is plate tectonics. Now, I'm assuming most of you have been exposed to plate tectonics in the past. Basically the idea is that the hard crust of the earth is split, along different boundaries into plates that move and grind against each other, move underneath each other, or push each other up. When these plates are moving against each other like that, they cause earthquakes, tsunamis, and volcanoes. And so these are the places where the earth is growing. New land is being created. So, the most famous crust boundary or whatever is probably the Ring of Fire. So the Ring of Fire extends all the way around the edge of the Pacific Ocean. And it extends from southern South America all the way to New Zealand. So it begins and ends in our two regions this week, South America and Oceania. Now, what's going on here is that you have this fault in the middle of the Atlantic. That's a spreading fault, okay? So the plates are moving apart from each other in the Atlantic and basically pushing everything in the world around, and so the Pacific Ocean is going under all of the continents, okay? So the Pacific Ocean is getting smaller and the Atlantic Ocean is getting larger. So that's what we've got happening here. Now, if we want to talk about the geomorphology of South America, the number one thing that we want to look at is the Andes Mountains. The Andes Mountains are caused by this long plate boundary along the west coast of South America. And you can see in the satellite that they're very high mountains, okay? Aside from the Himalayas, these are the biggest, baddest mountains around. How'd they form? So you've got this subduction fault. Subduction fault is only one kind of fault, but this one is one of the most dangerous because it's the one most likely to create the volcanoes that we are used to seeing, the big explosive ones. So South America is being pushed over the Pacific plate by the Atlantic, okay? Boop, 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 boop. Now, the Pacific plate goes under because ocean plates are heavier than continental plates. So the Pacific plate starts going under. Now, as it goes under, it gets pushed down into the molten mantle of the planet where it starts to melt. As it melts, it becomes less dense. Less dense things rise. So the melting crust starts to rise up when it gets through the plate that's on top of it. It erupts as a volcano. So this diagram is exactly what's going on with the Andes. The Andes are kind of the textbook version of the subduction fault situation. So that means that, you've got a lot of volcanoes in the Andes Mountains, and they extend all the way from southern South America up through Central America into Mexico. So, Ecuador, Chile. It's not uncommon for large volcanic eruptions to create their own weather systems. So it's super metal and awesome, but you will see lightning coming from volcanic ash clouds pretty regularly. Mexico. And all of this distortion and crunching and, erupting and just all of this mushing that's created all these mountains It's created all kinds of really cool geologic features like Rainbow Mountain in Peru. Okay, so you've got all these stripes. They were laid down horizontally over time. They were sedimentary rock. And then they were pushed and pulled and morphed into this ridge. So this is a favorite location for Instagrammers, but I also want you to remember this because we're going to come back to it tomorrow. So generally speaking, it's just a very geologically active region, South America. So in the last month, there's been earthquakes in Chile and volcano warnings in Guatemala. And there is a connection. I'm not crazy for putting South America and Oceania together. They are connected in ways that I don't think that we talk about enough. And one of those is that Hawaii, which is part of Polynesia, is the most vulnerable place in the world to tsunamis. Because of their location and the shape of their coastline, actually, Hilo, Hawaii, specifically. And most of their really big tsunamis have resulted from very large earthquakes off the coast of South America. And so every time there's a large earthquake in South America, Hawaii goes on alert because that's where the tsunamis come from. So this is connected, right? These regions are connected in at least that way. So the next question that we're going to talk about is, all right, so you've got these mountains, you've got these volcanoes, whatever. How does this physical geography influence the spatial distribution of humans and where human beings live? And to talk about this, we're going to go visit Australia and New Zealand. All right, we're going to cross the South Pacific all the way across over to Australia and New Zealand. So these two countries are similar. They're former British colonies. They're both still part of the Commonwealth. They have very high-rated democracies, rated higher than the United States. And they both really like black licorice for some reason. But there are quite a bit of differences as well. So here's the location of Australia and New Zealand, and they really are pretty far out away from the rest of the world, right? The population density centers. They're closest to East Asia, Southeast Asia, but they're pretty far out on their own. And so that gives them a lot of opportunity to develop independently when you're, instead of looking at, Eurasia. So the first thing I want to point out is that Australia is probably larger than you think by land. So this is a true size of Australia placed on top of the lower 48 states. And from east to west, the length is about the same for Australia and the United States. So it's a very large landmass, but it has not that many people on it, 25 million people, so fewer people than Texas. And so outside of the cities, what you'll find is a very low population density. It's a very sparsely populated continent, generally speaking. New Zealand, smaller than Australia, but also probably bigger than you think it is. So if you put it on top of the United States, the top part of the North Island would be at Chicago, and the south edge would be at New Orleans. So north to south, a pretty large piece of land. Population-wise, very small, 5 million people, smaller than the DFW metro region. So you also want to remember that they're farther away from each other than you probably think. I definitely used to think that maybe New Zealand was like an unofficial state of Australia, and no, they're 2 time zones apart from each other, and they're about the distance from El Paso to Orlando, so a long way, and it's a pretty long plane ride. It's about 2 or 3 hours. So they are independent of everybody else, and they're somewhat independent of each other, although they often do things like fight in wars together because they're frenemies. One of the big differences between Australia and New Zealand is the geology and geomorphology of these places. So Australia is one of the most seismically stable places on the planet, which means that there's not a lot of faults. There's not a lot of earthquakes. You're not going to see high mountains. You're not going to see volcanoes. What you're going to see is more like this in most cases, is very flat and with a lot of erosional features. Basically just things have been eroding and eroding and eroding and eroding for millennia. So this is Uluru or Ayers Rock, which used to be Ayers Rock. Now it's not anymore. And you're not allowed to climb it anymore because it's sacred. It's really, big rock. It's got some records. It's cool. But that is basically kind of, the Australia deal. So they don't have to deal with earthquakes or seismic risks. What they do have to deal with, though, is that almost the entire interior of their continent is desert or semi-arid. And humans don't tend to live in the desert very much, right? So how does this affect their population distribution? Well, almost everybody lives on the edges of Australia, and the vast majority in 4 cities, 3 of those cities are on the southeast edge. All right. So again, when you're talking about Australia, the imagination is to think about the shape of Australia, but the people really are down in the southeast edge. All right. New Zealand, on the other hand, like I said earlier, is part of the Ring of Fire. And so they are highly volcanic, right? You'll find volcanoes all over New Zealand. And that's why they have this wild, beautiful land of the ring or Lord of the Rings kind of vibe to them. Okay, it's rugged, and again, human beings don't tend to live in super rugged areas. There was a bit of a tragedy last year. So White Island there is a growing island. It's a volcanically active little island created by a volcano, and it's been a big tourist destination for a long time. And in September of 2019, it started to erupt while people were on the island. And so several people died. And this was a photograph taken by a tourist who managed to get on a boat and get off the island. So, you can see the volcano's just going crazy. And then there's these people over here trying to get on boats and get away. So this incident has kind of prompted more of a discussion about, well, what kind of responsibility do governments have when they allow volcano tourism? Because clearly, if you can't keep people safe, well, how can you? It's a volcano. Do you let people go walk around on it or not? So here's a physical map of New Zealand, and you can see it's got pretty much a spine of high mountains all the way down the southern island, and then a core of high mountains in the middle of the northern island. So where do you think people live? Do you think people are more likely to live at the top of a rugged mountain or near the ocean in the low areas where there's soil for farming? Yeah. Right? So basically, most of the population of New Zealand lives in 3 cities, Auckland, Christchurch, and Wellington. And those are down by the water. Humans usually will live as close to water as they can. So that is kind of how we can start to think about where populations are distributed within these large units that usually are presented to us as just one homogeneous unit, right? I also want to introduce the idea of hydrology in this lecture. So hydrology is the study of the Earth's water, and especially its movement in relation to the land. Okay, so we're talking about rivers, we're talking about lakes, and water is very much going to be responsive to the physical geography underneath, right? The geomorphology is going to determine where the water can go. So let's compare river basins from South America and Australia. So if you look at South America, we've got some massive river basins. In fact, the largest river basins in the world, okay? So that light blue, turquoise river basin in northern South America, That is the Amazon River, the largest river system in the world. And it's pretty amazing that it extends almost from the west coast to where it empties into the Atlantic Ocean at the east coast. And the reason for that is because of those Andes Mountains. So you've got that huge rise on the west side of the continent, and basically the rest of the continent slopes down to the east. And so the water that runs off the back end of the Andes Mountains goes into the Amazon and eventually all the way out into the Atlantic Ocean. It's pretty amazing. Meanwhile, if we look at Australia, that map looks super different. So you've only got really one, maybe two kind of well-developed larger river systems here. And you can see that the biggest one is over here where all the people live. That shouldn't be surprising at all. When we go out into the outback where it's arid, there are a whole bunch of teeny tiny little river systems that don't connect and don't connect to the ocean. So what's going on there? Well, basically what we're saying is when it rains, the water that falls in that area just runs to a low point and then evaporates off. So it's a very small basin. It never gets to the ocean, and the water doesn't stay there long enough to try to search for an outlet. Okay? So you get all these teeny tiny little river basins, and these streams that are shown here are almost always dry. Okay, so that's how your physical geography is going to influence how your rivers move and if water comes to where you are or not. All right, water, extremely, extremely important. So the last thing of this lecture, we're going to talk about the Anthropocene. Okay, so that's our word of the day, and it's one of my favorite words. And the Anthropocene refers to the new human era, where human activity drives planetary scale processes. And so you've probably heard geologic eras, Mesozoic, Cenozoic, in relation to dinosaurs. And there's a big argument currently that we are moving into a new era that is inescapably linked with human activity, and that's called the Anthropocene. So there are a couple of things that are hallmarks of the Anthropocene. One is that everywhere in the world, if you take a core sample of the soil, you will find a layer of radioactivity. That layer of radioactivity dates to the period between 1945 and 1963. If you take a geology lab, they'll have you do this because it's the easiest way to date your soil samples. Why is there a layer there? So 1945 was the year that the United States first used nuclear weapons, and the first use of them was dropping them on Japan. In the years after that, there was a lot of nuclear weapon testing from a lot of different countries, and they were just blasting radiation into the atmosphere, and it goes all around the world before settling down on the ground. In 1963, the Nuclear Test Ban Treaty went into effect, and so most countries now do not test nuclear weapons in that way. And so that radioactive horizon kind of stopped. But it's there, and it'll be there for thousands and thousands of years. Another hallmark is the amazing amount of plastics that we have produced and now discarded. So you may have heard about the Pacific Ocean garbage patch. That's a eddy in the middle of the Pacific Ocean, the size of Texas. That's basically just a giant dump. It's just a bunch of trash. Plastics will degrade into smaller and smaller and smaller pieces, but they don't really break down. And so animals will eat the pieces, and these pieces we're finding are becoming parts of sedimentary rocks, So you'll have a layer of sandstone and then a layer of just plastic and then a, layer of sand. And we have all kinds of new things coming out with this. So About a year ago, there was a big volcanic eruption on Hawaii, and it created a new beach. And a graduate student, a couple of months later, had a really good idea. He said, I'm going to go out there and I'm going to see how long it takes for a virgin, pristine beach to accumulate microplastics. Okay, these little pieces of plastic that wash up all the time. By the time he got there, only a couple months after the beach had been formed, it was already covered in microplastics. So there are no more virgin beaches left in the world. We have put enough plastic into the world that nothing is untouched. And we know that there are microplastics in the drinking water that most of the world drinks, including ours here in the United States. We just don't know what effect that's going to have yet. Increased greenhouse gases. I'm sure you guys have heard of this one in relation to climate change. We're going to talk about global warming and climate change in the next lecture. But essentially, our industry and our lifestyles and our automobiles and all of that have pumped out so many pollutants into the atmosphere that its chemical composition has changed in a way that's having a feedback loop effect on all kinds of systems, especially weather. Another one is widespread deforestation. We'll talk about deforestation a little bit more when we talk about biogeography. But when you cut down a whole bunch of trees like this picture here, by the way, is the border between Haiti and the Dominican Republic. And the Dominican Republic's the side that still has trees. When you cut down your trees like this, you speed up the process of erosion because tree roots hold dirt and rocks and stuff in place. And when you do that, now you have quite literally changed the structure, the shape, and the life cycle of those mountains. And so those are some ways in which humans have kind of accidentally made huge changes to their own environment, kind of to their own detriment. So, join me back here for lecture 2. We're going to start talking about climate and weather. And don't forget to take your quick and easy little review quiz after lecture 1. All right.